today we are going to start a chapter that is locus. What is the locus? The locus of a point is a path traced out by the point moving under a given geometrical condition. Say a locus of a point equidistant from a fixed point is a circle with a fixed point as center. Now, say a locus of a point which is equidistant from the two fixed points is the perpendicular bisector of the line segment joining the fixed points. Means what? AB are the two fixed points, and say PM is the perpendicular bisector of AB. P lies on this perpendicular bisector. We have to prove this one. That is what? At first we will prove this triangle and this triangle as a congruent. How? This is equals to this. This is common. This is equals to this. This is given condition. Therefore the triangles are congruent. What will say? That this angle and these angles are equal by simplicity. Now this plus this equals to 180 and angle AMP equals to 90. Now converse of this theorem, any point on the perpendicular bisector of the line segment joining the two fixed points is equidistant from the fixed point. Means what? If suppose PM is a perpendicular bisector, then we will prove that PA is equals to PB. How? You will take these two triangles. Now what we will say? That AN is equal to BM, angle AMP equal to angle BMP, each 90, MP equal to MP, common. Therefore triangles are congruent. What we will say? That AP equal to BP. Why? Here by RHS. By RHS, these triangles are congruent, and this is the CPCT, the given condition. What is that? What is the converse of this theorem? Any point which lies on this perpendicular bisector is equidistant from the two fixed points. Getting? And here in the first theorem, what was there? That if suppose P is a locus of point P such that the distance are same, then this point lies on the perpendicular bisector. Here, if suppose this is a perpendicular bisector, then the point lying on the perpendicular bisector should be are of equal distance from the two fixed points. Now, one more theorem we are going to discuss, that is the locus of a point which is equidistant from the two intersecting straight line consisting of a pair of straight lines which bisects the angle between the two given lines. This is what? AB and CD are the two lines, given lines, they are being intersected, and these are the angle bisectors. And locus of a point is what? This one and this one. So what is there? That if suppose this distance is equal, then it will lies on the angle bisector. We have to prove. Now what we will prove here? That in triangle OMP and ONP, OMP and ONP. So this is OMP and ONP. We will take these two triangles. We will prove them as a congruent. Once they are congruent, what we will say? That angle BOP equal to angle NOP. Got? We will say that one by CPCT. That means P lies on the angle bisector of BOD. That means what we are going to prove? That this line is P lies on the angle bisector of this angle, that is your DOP. Any point on the bisector of angle is equidistant from the arms. That means what we are going to do here? That we will prove these two triangles as congruent. After proving this congruent, what we will say? NP equal to PM. Why? By CPCT. Now, see dear student, here in this chapter, that is a locus. What we are going to read here? That say how to find. I am showing you some constructions here. Say find a point P in a given line CD which is equidistant from the two fixed points. That means what? Say if suppose any line is there, that is CD, and this line is given AB. Okay, this is given AB and this is your CD, any line CD. Now how P lies on this line CD and which is equidistant from A and B. What we will do? We will do a perpendicular bisector of AB. Then we will join this one. Say this is the point P which lies on CD, which is equidistant from these 2 points. Getting? Which is similar to the first theorem. Now the second one, say find a point P which is equidistant distance from the 3 given non-collinear points. Say this is one point, this is another point, and this is another point. If you will join this one, if we will join this like this, then we will do a perpendicular bisector of this one. Then after that we will do a perpendicular bisector of say this one. We will join this one. Getting? Now this is the point P which is equidistant from this arm AB, and this is your C, non-collinear points. Now after taking this one as a center, this one as a radius, if you will draw, then we will get a circle which touches all these 3 points like this. Now construct a triangle ABC, BC equal to 5 centimeter. What we will do here? See dear student, at first we will do draw BC of 5 centimeter. Then CA 4.6 will take and will give an arc like this. Then AB equal to 3.8 will give an arc, we'll cut here, we'll join these two. Now, see. Okay, now how to find a point which is equidistant from BC and AB? Then what we'll do? We'll do a perpendicular bisector of BC, we'll draw that one. Then after that we'll draw an angle bisector here, we'll join this one. This is a point P which is equidistant from AB as well as your BC. Getting? Now see, some constructions are given in the example. See dear student, what you all have to do? You all have to practice all the examples nicely as well as the constructions given in the exercise 14. Okay, any problem? Then after that we will discuss. Got?